Watch this video, you must. Learn to make this you will.
I've divided this tutorial into 3 parts. First we'll assemble the hardware, then we'll prepare the images. Finally we'll write the sketch and upload it to the ESP32. This screen I'm using is the WaveShare 1.5 inch OLED. You can get these on Amazon. They're not the cheapest OLEDs around, but they have top-notch build quality and the image looks amazing. So this is how you connect up the OLED to the ESP32. So there are 7 pins that need to be connected up in total. The ones in bold are really critical and these must be connected to the pins as shown. So VCC on the OLED goes to 3.3 volts on the ESP32. GND goes to GND, this is the ground. DIN goes to GPIO23. CLK goes to GPIO18. So the 3 remaining pins on the OLED display are CS, DC and RST. I've assigned these to GPIO 0, 2 and 4 respectively. If you're already using these pins, you could use other digital pins. So that's pretty much it for the hardware. Now we need to prepare some images. So I would strongly recommend that you prepare the images in a graphics package. So we'll need to prepare them to be the right size. So what I'll do is to select part of the image, and we need it in the ratio of 2:1, so it should be twice as wide as it is high. So I will crop that and then resize it and save it as a PNG. In this example I'm using images that are 128 by 64 pixels. I believe you can store up to 32 of these on the ESP32. So once we've saved all the images, now we need to convert them into a format that we can use with the ESP32. To do this, I recommend using a little utility called LCD Image Converter. I've linked to it in the description. So I'll go to File and then open our image. So as you can see, the image is here. It's worth double checking to ensure it's the right size, so it is 128 by 64 pixels. So what you need to do now is to choose Options and then Conversion. And in the preset, we need to select Color R5G6B5, so this one here. Then you need to click on the Image tab, and for block size, you need to select 16-bit. And then click on Show Preview here. So this is the code for the image here. So you can click on this text box here and press Ctrl A on the keyboard to select all. And then Ctrl C to copy it into the Arduino IDE. So you need to repeat this process for all of the images that you want to use in the sketch. So there are 2 files, the regular.ino file and the quote images I put into a header file. Because the image data is quite large, I've put them into a separate file that keeps the main sketch nice and straightforward. So I'll come back to this file, but first I'll click on quote images. So all you need to do to replace an image with a different image is to replace one of the variables here. So image 1, this is all the data. There's quite a lot of it, so if you're cutting and pasting, then ensure you leave the closing angle brackets here on any of them. So as you can see, there's image 2, image 3 and so on, image 7 at the bottom. We must use progmem. This attribute here is really important. It's a bit of a throwback to the Arduino Uno. The ESP32 is somewhat different for its memory. The Adafruit graphics library that we are using requires that the image data is in the progmem part of memory, so that's why we have to include that here. Now here's a walkthrough of the main sketch. So at the top we include the libraries, so it requires the Adafruit graphics library and also the SSD1351 library. This is for the particular OLED screen that we're using. So if you try to compile the sketch and it complains that these libraries are missing, you can go to Tools, Manage Libraries, and then search for Adafruit and you can install them there. If you click on Type and just show Installed, then it will also show whether you've got it or not. And you can see it's here on my PC. SPI.h you should already have because it's part of the ESP32 code. Quote images is this file here, and it must be in the same folder as the sketch. Something that really confused me while I was writing this code is that if you use your own include file, then it must be in double quotes rather than angle brackets. If you put it in angle brackets, it doesn't seem to be able to find it, even though it's in the same folder as the sketch. So next we set the screen width and the height for the OLED display. If you're using one with different pixel dimensions, then change this. So here we define the pins used with the display. So 18 and 23, these must stay the same. These three pins here, 0, 2 and 4, can be changed to other pins if you're already using them. Just remember to match them up with your actual circuit. And next we have some color definitions. So if you want to change the color of the font used for the quotes, then you can use one of these colors here. So this configures the display, sending in all of these settings. Next we have an array of quotes. So you could add more quotes here or replace the existing ones. Just bear in mind that if it's too long, it won't be able to fit onto the screen. So we have some more variables here. Image width and height, these are the dimensions of the images that we're using. So the Yoda images are 128 pixels wide and 64 pixels high. So image X pos and Y pos are the starting positions for where the images will appear on the display. And I've offset the vertical by 10 pixels so they appear a bit further down on the screen. Then number of images, this variable here is set to 7, so we currently have 7 Yoda images. Next we'll look at the setup routine. So I have initialized the serial port so you can print data to the serial port and then appear in the console. So go to tools and then serial monitor. So this can help with debugging purposes. Incidentally, you can potentially rotate the screen. So if you uncomment this line here, tft.setRotation, and then you can rotate the screens. Because we're using random data, then we set a random seed. This number can be anything. So now we will come to the loop. So quote number chooses a random quote. So render quote will put the text on the screen. So this function here, it basically sets the cursor on a specific part of the screen, sets the text color, I'm using white, and then prints the text on the screen. So to draw the image, it uses this draw random image function. I will just mention that after it draws the text, there is a ½ second delay, and then there's a 5-second delay after the quote appears, and then it goes back to the top of the loop and repeats again. I think the delays make it look a bit better. So if you wanted 10 seconds here, you could change this to 10,000. So draw random image, this actually puts the image on the screen. So it first selects a random number, and then there is a switch statement, and it will call the tft.drawRGB bitmap function, and it will have a different image according to which random number there is. So draw RGB bitmap, that takes the image X position, Y position, the image data, and then the image width and the height. Unlike in C# programming language and other programming languages, if you set these to different dimensions, it won't actually resize the image, but in C# it does. So now the code's written, I will connect the ESP32 and then upload the sketch. So go to sketch and then upload. You probably will have to hold down the boot button on the ESP32 while it's compiling. This is especially true if it already has a sketch on it. So you see it says connecting down here. Once it starts saying writing, then you can release the boot button. Okay, the ESP32 has reset and the images are appearing. So there you have it, a nice little device to help us motivate ourselves in our daily lives. Thanks for watching.